Welcome to Lecture 7 for Unit 1. This is the last lecture in Unit 1. My name is Jorge and this is for Statistics 2023. So the objective for this particular lecture is that we're going to be talking about bar graphs, Pareto charts, time series graphs, pie charts, stem plots, scatterplots, and also box plots. When we do a box plot, we'd have to do the 5-number summary, and I'll talk about that in class more. So the first thing we're going to talk about is a bar graph. And the bar graph just represents data by either using vertical or horizontal bars. And the height or the length represent the frequency of the data. And the data that we're going to use is how much money do freshmen spend on certain categories the first year of college, right? So we have electronics, dorm decor, clothing, and shoes. So we're going to go ahead and represent this data in a bar graph. So here's the data that we have, and here are the two different bar graphs that we can construct. So if you notice, the difference between a bar graph and a histogram is that the bars don't touch each other. So I'm going to show you real quick how to construct these two, and I'm not going to tweak them or anything like that because I showed you that previously. So what I want to do is I want to highlight the entire data, both columns, and I click on Insert. And then I'm going to just click on the first option that I get, and here I get the bar graph. And then after that, of course, I just put my chart title, change the put titles on the axis, and then I'm done with that. Now the next type that we can do would be the horizontal, and again it's the same thing. Just highlight, click it, and then you go and then tweak it. So the way that these look is like this, and of course the one on the right I didn't put any titles or anything, but you have to make sure that when you do this, and especially if you're doing something you have to turn in, that you put all of your titles, chart title, vertical and horizontal axis need to be labeled correctly. Alright, so let's go back to the next thing we're going to talk about is Pareto chart. Now this is a bar graph. However, it represents the frequency distribution, and what it does, the bars are displayed from the highest to the lowest. So here's my raw data, and these are just 5 cities with the number of homeless people in each city. So I'm going to go ahead and put this raw data in a Pareto chart so we can see the differences. So here's my data. Now there's two things I want to talk about. Here's my data already cleaned up from the largest to the smallest, but here's my data when it's not cleaned up. So how do I go from this to this? And what you do is you look at the values, and I want to put it from highest to lowest. So I just highlight the values, and then I click on the sort and filter. And what I want to do is I want to click on sort from largest to smallest. And then when I do that, I'll get this this question: do you want to expand it or continue? And I want to expand it, because if I don't expand it, what's going to happen is it's going to order this column, but it's going to leave this column the same. So I want to click on expand the selection, and then I click on sort. And if you notice, all the values are where they should be, right? So everything is the way it should be. So then the next thing that I do is I just highlight the data, go to Insert, and I'm just going to go ahead and construct a bar graph. And then of course I just tweak it with the title and all that. So this is what it looks like once it's all completed. And since the bars don't touch, you're welcome to leave them the same color. You can change them if you want to. So the next thing I want to talk about is a time series chart. So time series represent data that occur over a specific period of time. Now the unit of time should be consistent. That means that if you have a data set that's in minute, you have some in minutes and some in hours, then before you graph them, you have to put them all in the same unit, inches and feet and so on and so on. So don't mix measurements taken every day with measurements taken every week, because then you'll be lying. Oh, it's a bit difficult to understand what's going on. So here's some data. This is 20 weeks and the distance that a runner ran each week, and the distance is in miles. And so we're going to go ahead and display this in a time series chart. So here's the time series chart. So I'm going to show you how to do that one. So here's the weeks 1 through 20, the distance for each particular week. So my raw data is nice and clean. So what I'm going to do then is I just want to highlight the miles. Click on Insert, and I'm going to go ahead and put a line chart, and that's what it looks like. So then at this point in time, I want to add, well, if the data was different, I would go ahead and change my horizontal, but the nice thing about it is automatically puts it from 1 to whatever number, how many data points you have. So what does it look like once you put all your titles and all that? This is what it looks like, and that's a time series chart. Okay, so let's go to a pie chart or pie graph. So in a pie chart, the circle is divided into sections or wedges, and each size is according to the percentage of the frequency in each category of the distribution. Pie chart is good if you have only a few number of segments. It says 10 or fewer, but normally, 5 or 6, it's okay. You want to kind of stay away from a pie chart. It's not the best looking thing in the world, but if you have to do it, Excel can do it for you. And so here's the data that we're going to go ahead and do. And this pie chart just has the type of snacks in pounds of snacks that are eaten during a Super Bowl. So here we have the data. So we're going to go ahead and go to Excel. And so here's my pie chart. So what I'm going to do is I'm going to show you how to get the percentages and how to get the degrees and all that. So I'm just going to, let me move this out the way. So here I have my snacks, and here I have the pounds, and it adds up to 30, and that's what I should have. So the way that I get the percentages, and I'm going to show you how to do that now, is I know that I have 30. All right, so what I'm going to click on is I'm going to click on equal. I'm going to highlight this, and I'm going to go ahead and divide it by 30. And if it's not in percent, you want to go here to number, and you want to make sure that that particular number is in percent with 1 decimal place, and you click OK. And now what I'm going to do is if I click, just drag it, it's going to continue to divide this cell by 30, and if I drag it again, it's going to divide this cell by 30, and if I drag it all the way to the bottom, it divides each cell. So I'll show you the formula. So if you notice, this is the B4 cell divided by 30, the B5 and the B6, and then the way that I add them up is, I'm going to show you how to do that. So you click on equal, and then you type in the word sum, open parentheses, and then you just highlight what you want to add up and just press enter, and it'll give you the sum of that column. And the same thing here. So how do I get the degrees? Well, what I'm going to do is I'm going to multiply this cell by 360. So what's 37.3% of 360? Well, that's the way I do it. So again, you type in equal, highlight the cell, asterisk, and then you press 360, and it gives you the degrees, and you do that for each one. And of course you add it up. So the next thing that you do is you're going to go ahead and construct the pie chart. So I go to insert. I just want the first, oops, sorry. So I want to highlight this, insert, and now it has it this way. So it's not a bad looking chart, and so you're welcome to leave it that way if you want. I tend to like to put the labels inside, so I tend to do this. It's not the best looking chart in the world, but still it's a pie chart, so it's the best that we can do. So this is what it looks like once you tweak it all. So my suggestion is you have this file available, just get in there and start playing around and see if you can replicate the graph that I have there. So the next thing that we're going to talk about is I'm going to do a pie chart again for the Army inductee blood type. And if you remember, this was from probably the first or second lecture, I believe. So let's go ahead and look at that, what that looks like in a pie chart. So again, here's the data, here the blood type, the frequency for each. I added up the columns, my percentages, my degrees, and then I went and did my pie chart. So again, this is another way of displaying that data that we had, and this is what we call categorical data, and this is the way that you can do it in a pie chart. So let's talk about stem and leaf. And a stem and leaf is a data plot that uses part of the data values as a stem and then part of it as the leaf to form group of classes. So here's some data. So this is infant mortality rate per 1,000 birth for 221 countries. So this is from the CIA Fact Book 2012. So the legend is that the 12 So if I have 12 to line in 2, that's equivalent to 122. So that particular country has 122 infant mortality per 1,000 births. So so it's easy for you to see the value. So the 1 to 9, you have 94, 94, 97. The ones the 8 is 80, 84, and so on and so on. So that's the stem and leaf plot. I'm going to tell you right now, stem and leaf plot, it's better to use other softwares. There's some websites that you can do it on, and I'll go ahead and talk about that in class. Excel really, I mean, there's ways you can do it, but I just don't think it's worth the hassle. All right, Scatterplot. Scatterplot is a graph of the ordered pairs. So you have independent and the dependent variable that you're trying to see if there is some relationship. You just want to go ahead and graph them together to see what's happening. And so this is what it looks like. So this is percentage of internet use for a particular countries and the life expectancy. So is there a relationship between internet use and life expectancy and expectancy in particular countries? So the first one on the left, I used R, and this is an open source software. And then the one on the right, I use Excel. And if you notice, they're the same graph. The one in R looks a little cleaner, but the one in Excel actually will do the work. So either one is good to go. I really won't get into R in this course, but some of the graphs that I do use to display in the lectures, I'll do them using R. So next thing we're going to talk about is the box plot. And a box plot is simply a graph of the data set that we obtain by finding the 5-number summary. And the 5-number summary would be the minimum value in the data set, the first quartile, the median, the third quartile, and the maximum. And we'll talk about this later in class. But the way that looks like is like this. So this is what a box plot looks like. So here's the minimum value. Here's the first quartile. Here's the median. Here's the third quartile, and here's the max. Now, we talk about real quick about misleading graphs. So graphs gives a visual representation that enable the reader to actually look at the data and analyze it and make any interpretations that they want to. Now, a lot of times we get lied to by graphs. So here's one: vehicles on the road, manufacturers, competitor, and then competitor 2, right? So it looks okay. I mean, you can see that there's a difference between them, and but look at the scale. It goes from 94 to 100. Now, if I were to change the scale from 0 to 100, you can say, well, there's no difference between those. So you have to be careful. Always look at the scale when you look at a graph to make sure that they didn't tweak it. So here's another one. This is projected miles per gallon. So here the scale goes from 0 to 25, right? And the line looks pretty flat. So you would say, hey, what's going on? They're not getting any better. But if I tweak the scale, now it goes from 21 to 24, it looks like there's a huge difference, right? From 2008 to 2011. And that's the end of lecture 7 for unit 1. Thank you.